Namaste to everyone. I welcome you all in my YouTube video channel. Today, I will deliver lecture on linear algebra, chapter vector space of n-tuples, lecture number 1, in which I will give the concept of n vector, algebra of n vectors and the n vector space. Firstly, I would like to give you the concept of ordered pair, ordered triplet and ordered n-tuple. Now we start with an example. Let I invite Mohan and Sohan in lunch. Mohan is denoted by M and Sohan is denoted by S. If I denote this concept by MS, MS means I invite Mohan and Sohan in lunch. If I write this as SM, then this means I invite Sohan and Mohan in lunch. Two concepts are same. If I invite Mohan and Sohan in lunch and if I invite Sohan and Mohan in lunch, both concepts are same because two persons, Mohan and Sohan, are invited in lunch. Here MS and SM be same, but if I talk about that 2 3 and 3 2 are 2 points in a plane. Here this is origin, this is x-axis, this is y-axis. Here this 1 2 3 4, here 1 2 3 4. Now 2 3 means we take 2 in x direction and 3 in y direction. This point is 2 3. Let name of this point be P. And 3 2 means we take 3 along x axis and 2 along y axis, means this point. This is Q. 3 2. So these 2 points are different. So here 2 3 not equal to 3 2. These are pairs. Here also these are pairs. And here also these are pairs. These pairs are same, but these pairs are not same. Here only order of numbers are changed. Here 3 after 2, here 2 after 3. So order is important. Here order is not important. Here M after S, here S after M, but both are same. Both pairs are same, but here order is important. If order is changed, then two pairs are not same. So these type of pairs are known as ordered pair. So we use the term ordered pair. if in a pair the order of two entries are changed, then if the meaning is changed, then that type of pair is known as ordered pair. Similarly, we may write ordered triplet X, Y, Z, three entries. If the place of the entries are changed, then if the meaning is changed, then this type of triplet will be known as ordered triplet. In the similar manner, if we have n entries x1, x2, xn, and if the order of entry is changed, then meaning is changed, then this type of n entries is known as ordered n-tuple. This is ordered n-tuple. This is ordered triplet. Now we define n vector. Any ordered n-tuple of numbers is called an n vector. This is ordered n-tuple of numbers x1, x2, x3, xn. These are called components of n vector, and this vector is denoted by capital X. Let capital A be a matrix of size m by n. Here we have m number of rows and n number of columns. Each row of the matrix will be an n vector, because here we have n number of entities in a row. If we write x1 a vector, then a11, a12, comma a1n. This is a row vector. Similarly, we get m number of row vectors. In this row vector, we have n number of entities. So this is n vector. And each column will be an m vector. Here column. This is first column. This is second column. Similarly, this is nth column. In the first column, we have m number of entities. So, if we write this by y1, a11, comma a21, comma a m1. This is also m tuple. So this is a m vector, not n vector. Row vector is n vector and column vector is m vector. Now we define about zero vector. A vector whose components are all zero is called zero vector and will be denoted by big zero. This zero vector contains component zero number, 0, 0, 0, 0. All components are zero number. So this is zero vector. Now we discuss about algebra of vectors. In algebra of vectors, firstly we define equality of two vectors. Let capital X and capital Y be two n vectors. N vectors means number of components of vector capital X be n, x1, x2, xn, and components of yb, y1, y2, dot 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 yn. These are two n vectors, means number of components be n. They are said to be equal if a corresponding components are equal. That means here first component x1 equal to first component y1, second component x2 equal to second component y2, and similarly nth component xn equal to nth component yn. Then we say that these two vectors are equal, that is capital X equal to capital Y. Now we define addition of two vectors. Let x and y be two vectors. These are n vectors because here number of components of x and y be n. The addition of x, capital X and capital Y is denoted by capital X plus capital Y and defined as capital X plus capital Y equal to a vector in which components are sum of corresponding components of two vectors. Here x1 plus y1, here x2 plus y2 and xn plus yn. Now we define multiplication of a vector by a scalar. Let capital X be an n vector. Here number of components of capital X be n, x1, x2, comma dot 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 xn, and k be a scalar. Then multiplication of the vector capital X by a scalar k is denoted by k capital X and defined as k capital X equal to a vector whose components are k multiply each components of this vector capital X, kx1, kx2, comma dot 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 kxn. Now we discuss about the properties of addition and scalar multiplication of vectors. Let capital X, capital Y and capital Z are n vectors. Small p and small q are scalars. Then these are the properties. Number one, x plus y equal to y plus x, means vector addition is commutative. We may prove this. Let capital X equal to ordered n-tuple x1, x2 dot 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 xn, and y equal to y1, y2 dot 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 yn. Capital X plus capital Y equal to x1 plus y1, comma x2 plus y2, comma dot 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 comma xn plus yn. Here x1 and y1 are numbers and numbers are commutative. So we may write this as y1 plus x1, here y2 plus x2 dot 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 comma yn plus xn, and we may write this as capital Y plus capital X. So first property is proved. This is commutative law. Similarly, this is associative law for addition. Capital X plus bracket capital Y plus capital Z equal to bracket X plus Y bracket closed, plus z. Here PB a scalar and x, y are vectors. Here we see the distributive property by scalar multiplication. Px plus Py. Number 4. P and Q are scalars. These are under bracket. P plus Q and x be vector. So this is another type of distributive law. Px plus Qx. This is number 5. Here P, Q are scalars. P under bracket Qx equal to PQ under bracket x. We may prove these properties very easily similar to this. Now we define the linear combination of n vectors. An n vector x can be expressed in the form of capital X equal to k1 x1 plus k2 x2 plus dot 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 plus kn xn. This is number 1, where k1 k2 dot 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 kn are scalars and capital X1 capital X2 dot 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 capital Xn are n vectors. Then 1 is said to be linear combination of n vectors x1 x2 dot 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 xn. These are capital X1 capital X2 capital Xn, and this form is called linear combination of vectors. Now we define n vector space. The set of all n vectors of a field F is called n vector space over the field F. It is denoted by Vn under bracket F. Here we have term n vectors of a field. Let X be an element of n vector space, then X is expressed as x1 x2 dot 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 xn. The x1 x2 comma dot 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 xn all are elements of the field F. So here we have mentioned that set of all n vectors of a field F is called n vector space over the field F. Over the field F means when we multiply scalar multiplication of the vector x. This is a scalar. Scalar means this is the element of the field. P belongs to F. So scalar multiplication of a vector with a scalar means that scalar quantity must be the element of the field F. And since field F, P be an element of field F, so Px will be Px1, Px2 dot dot Pxn. Multiplication of two elements of the field be again element of the field. Px1 is an element of the field, Px2 be the element of the field, and dot 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 Pxn will be the element of the field F. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.